Welcome, ladies and gentlemen, to Module 3, Chapter 5. It has taken me many months in order to get through Module 3, and I do sincerely apologize for taking so long. If you have been using my videos to study for your chapter tests, and all the modules that you were trying to get through, I am sincerely sorry that it has taken this long to finally get through Module 3. And I know I still have additional modules to get through, and they're coming out with a cyber one soon that hasn't been published yet, but it's coming out soon, and I haven't read it yet because I'm a senior member and I never had to take it, so it's not quite material that I know yet. But today we are covering weather systems and changes. Now, this video is going to be a little bit challenging to verbally describe. And when I was learning stuff for weather, when I was getting my private pilot's license, I used videos to better understand how fronts work, which are explained on this page. If you are a visual learner, I will do my best to describe each of these fronts to you, but please know that if you're struggling with understanding like what an occluded front is, you can always look it up and find a separate video that just visually shows what it is, like the hot versus the cold and the low pressure versus the high pressure. Like it can get a little confusing, so that is all I will say about that. An air mass is a giant amount of air that has the same characteristics and temperature across that area. So like in my local area, there is a specific air mass where I live. And where you live, it might be slightly different. And depending on the movement of the air masses, that can determine the weather conditions that you're experiencing, what kind of clouds you'll have, and if you get any precipitation in your area. There are different types of air masses, which include polar, Arctic, tropical, and equatorial. Clearly, the Arctic and the polar air masses are colder than the tropical and equatorial ones. Then there's also continental and maritime. And there is a map here. I will show the map very briefly. Oh, my poor book. Oh, it's not doing too hot. Here is, let's see if it'll focus. There we go. So it shows you in here the continental versus, I hope you can pause it and see that. I'm not going to hold it up to the screen forever, but there are different classifications of air masses associated, whether it's on a continent or if it is over, if it's a maritime one, which means it's over the ocean. So let's talk about fronts. Ba-doop boop. So there's warm, there's cold, there's occluded, and there's stationary. And depending on how these fronts are interacting with each other can determine a lot of different things. And so there are different symbols associated with warm, cold, stationary, and occluded. So if you're looking at the little diagrams and you think of little bubbles, it's basically like a red half circle that's been shaded in with red, and you've got a bunch of those. That's associated with a warm front. So if you think of maybe like a hot tomato instead of a hot potato, you've got hot tomatoes. I don't know, whatever works best for you. But then the cold ones are like blue icicles where they're all going in the same direction as well. When you've got stationary, you've got the half circle of the red on one side, and you've got the blue on the other, which is associated with like the cold and the warm, and they're pushing up against each other. And when you've got occluded, all of the symbols will be on the same side of the line. So if there is warm taking over cool, then it's typically associated with light precipitation, and if it's cold taking over the warm, then it's associated with the development of cumulonimbus clouds. Let's say a cold front and a warm front bump into each other, but there isn't really enough movement between these air masses, then that can create that stationary front. And this lasts until one is eventually stronger than the other, and it bests the other, and it's like, get out of here, and then it'll overcome the other air mass. So in the cases of a warm front, typically the warm air will come in, and it'll actually push down the cold air. When it's a cool front, then it just kind of moves across the land, and the warm will just kind of be pushed away. The cool fronts actually move more rapidly, and that's kind of why that develops the cumulonimbus clouds, because it creates a lot of instability in the air. There are two different types of occluded fronts. There's a cold occluded front and warm occluded front. I definitely recommend looking at a diagram in depth. Like the one in the book is pretty good. It's a horizontal view of what's going on. Occluded fronts typically include 3 different air masses, which can be warm, cool, and then the coldest one. And depending on if the cool air that's coming in is colder or warmer than what's already there, can determine whether or not it's a cold or warm. We'll talk briefly here about severe weather. Cumulonimbus clouds are associated with really bad weather, and hurricanes, tornadoes, and thunderstorms are all very dangerous. If you know that you are in an area that is about to be hit with severe weather, then please make sure you go inside to safety and go to a place in your house that will protect you from any harm, such as being in a basement where you don't have any windows. So if there are windows in all of the rooms of your house, try to go to the most centralized point. And if you can go into your basement, if you have a basement, then it's definitely recommended as a safety procedure, and have survival supplies such as food and water available in that basement. The stages of a developing cumulonimbus cloud include building, maturation, and dissipating. So at first, it starts building up, and it's like, oh, I'm going to be big, and it's big, and then it goes away. The book also includes this cool fact that there are about 2,000 thunderstorms happening any place in the world at any given time, which is pretty cool. It's also kind of terrifying because thunderstorms are very dangerous, and you should not be outside during thunderstorms, so please be safe. But this is not a lightning/thunderstorm safety briefing, maybe for another day. So to better understand the stuff that I talked about in this video, I didn't go super in depth on occluded fronts, but that's because I think it's really beneficial to look in depth in a video summary of the differences between warm and cold occluded fronts. So if you look at this diagram here, this is an occluded front, right? Because it's got the 3 air masses. You've got the cold, you've got the warm, and you've got the cool. The cool is a little less warm than the cold front, and so that's how we know that this is a cold occluded front, because this colder air is cooler than this air here. If it were the opposite, where it's cool versus cold, then there would be a front formed right underneath the warm air as the cold air continues to push up, but the cool air is also pushing in. I know occluded fronts are confusing. I warned you at the beginning of the video, and I'm sorry if it is a little bit challenging, but I hope that video helped clarify it a little bit. The main thing is that you just know that there are 3 fronts of air associated with occluded versus the warm, the stationary, and the cold fronts, which are just associated mainly with 2 different air masses. So that closes Module 3. I hope you enjoyed this video and you found it to be a useful study resource. If you do like it, just let me know. I can continue to do more with the Aerospace Dimensions books. To be very honest, weather is some of the most challenging stuff for me when I was studying and when I did my spot stuff and when I did private pilot's license. It's not a strength of mine, but I hope that it is a strength of yours now after watching this video. So thank you so much for watching, and that is all, folks. Until next time, toodles.